Welcome to Ham Radio Adventures 10, a 2-meter copper dipole. December 2023, K3 MHW, I am Mark. Thank you for watching. Hello everybody and welcome to Ham Radio Adventures 10. Ham Radio Adventures 10 is going to be about a 2-meter copper dipole build I was playing around with, and I'll explain that in a little bit. Won't be a long video, but before I get to 10 and the dipoles, I had some requests from Ham Radio Adventures 9. That's where I direct buried some 7/8 inch hardline, some direct bury Ethernet, LMR 600. I was moving my radios from the pole barn into the house, and in doing so, of course, I had to dig a big trench. And a few people have asked to see the end result of all the holes I dug. So let me run that real quick. It's 30, 40 seconds, and we'll come back to the antenna build. So here we go. The first 75 feet had to be hand dug because of underground PVC for electric. There was sewer, gutter drains that go underground, etc. And of course, I destroyed the grassy area. This shot is the cable all buried through the grassy area and roughly compacted in. This is the start of the trench through the driveway and to the entry panel to the pole barn. Now here's a shot of the driveway, rough backfill. I then rototilled the grassy area 4 feet wide, compacted, and seeded. Then I put straw down to hold the seed. After compacting and filling the driveway, I put back what stone was still there. I let the area settle in for a few weeks until I got about 3 tons of stone, and I did some touch-up work. And here is a shot after the new stone was spread out and the grass has grown back in. It was a mess at first, but all looks like we never disturbed it in the first place. Thank you, Rich, for the excavator. I really appreciate it. Okay, let's get back to Ham Radio Adventures 10. I'm K3 MHW, Kilo 3 Mike Hotel Whiskey. My name is Mark, and welcome to my humble abode. And I belong to a radio group, a local group called Worcester Radio Group. And we do a lot of volunteer work where we use our handy talkies, some base stations. And, we'll do, there'll be some races, there'll be parades, whatever it may be. And we provide communications between points for those people so they can tell what's going on. For instance, when they do a 26-mile marathon, we spread out our guys in case there's a problem. Excuse me. We can call EMS in or whatever we need to do. But we help out. And the last time we did this, we were in deep woods, and the handy talkies were not communicating very well. So I thought about that for a while, and I said, well, I know there's a million dipole builds out there on YouTube, but let me see if I can put together some kind of 2-meter dipole out of stuff I have laying around the house here. I live on a large property out in the woods, and I have a lot of stuff that I store in case I need it. Copper fittings, various pieces of wood. So I figured, let me see if I can put together a dipole. And the results were really kind of amazing. I'll show you the readings from my rig expert, and I was quite pleased with how it worked out. We even ran a test where I was on my Anytone handheld using the dipoles, and I was able to 5.9 plus 10 over communicate directly with another person 5 or 6 miles away through my woods. So it seemed to work out very well. And when I went back to the rubber ducky on the Anytone, there was a lot of noise and he could barely hear me. So it looks like the antennas are working well. None of this is scientific, except for, I guess, the rig expert readings. But let me show you what I did and how I put them together. And I'll give you the end results at the end of the video. So enjoy. I hope you like it. And these antennas work really well. So see if you can, maybe you can pick up something by it. Maybe you can't. Now, I made two antennas to begin with, and each one of them has a little bit different readings, but they're both very strong, very good signal with a handheld. So here we go. So let me show you a close-up of the completed antennas, and then I will show you the individual pieces the way I put it together. This is a piece of PVC I had laying around the back. I had some U-bolts, as you can see from the back, and I used 1-inch PVC, 1-inch PVC, and you'll see this little bump out here. I have one that when you put it in the holder and put a bolt through it just to hold it steady, it's horizontal, the antenna, and if I want to, I can turn it and we can make it a vertical antenna. So it depends on your needs, but I made it this way. Now, if you look close up, I had, use my pointer here, I had this little PVC connector, and I used it just to space out the 3/8 inch, this is 3/8 inch copper that I had laying around. I used a piece of coax LMR 240 I had laying around, and I soldered by using a torch. And of course, always use flux when you solder the copper. And I soldered the ground and the center conductor onto the antenna. Now, you'll also notice where this zip tie is, that this 3/8 inch copper actually goes in this far. So the antenna coax is soldered approximately 3/4 of an inch into the copper strips. So here's the LMR 240, and it goes to an SO 239 connector. Again, these are parts I had laying around. This copper, okay, is cut to 17 3/4 inches, 17 3/4 inches. And on the ends, what I did was, I have a rivet insert tool. We usually call these things nutserts, but there's a cap on the end of the 3/8 inch copper, a hole drilled in the center, and there's a rivet put in there with threads. And this is, I think, an M4 or an M5 bolt. And I can take this bolt and adjust it in and out to adjust the antenna. And right now, this antenna's peak performance is right where these are set. As you can see, there's maybe 1/4 to 3/8 of an inch sticking out, and that made the antenna pretty close to, I believe this one was 1.18 or 1.2 to 1. I want to show you the second one also, but this is how I put it together, and this is how it mounts, goes into the pole and mounts with a bolt. Now this is the second antenna I made, and this one, the performance is unbelievable. You'll see in a little while my Rig Expert readings on it, and I'll go over it a little bit. There's a couple differences in this particular dipole. This copper rod is 17 7/8 inch, 17 7/8 inch long, end to end. What I did was I inserted those rivet nuts on the end cap. I drilled the center out. I'll show you how I did that later to get it centered. I put stainless steel ring terminals, soldered them, and then screwed them in. And this is number 14 copper wire that comes to the SO239 for the antenna feed for the coax. All I did with this one, I didn't waste the spacer. I just zip tied them in. It's very sturdy. I originally tried this with 1/4 inch copper, but they just bent too easily and it was always getting crooked. The 3/8 is strong. Hopefully I'm going to build a 1/2 inch version also and see how that works. But this is the same thing. I have what looks horizontal and a vertical. So when I put it, when I mount it in the mast vertically, the antenna is horizontally polarized, and I can turn it on its side, put the bolt through it to hold it in place, and I can be vertically polarized. You'll also notice at the end, I did put nutserts in on the end with a cap. However, I didn't need them. This antenna is very, very resonant where it is right now, and it's pretty flat across the band. So let me show you how I put this thing together. Here's the antenna mounted on a temporary test stand, and I'll eventually show you the stand I actually used to test this thing out. And by the way, this antenna is CAT approved and inspected. Here's the antenna analyzer reading of the first antenna. You'll see the SWR is 1.18, and that was flat across the whole band. I measured everything in the center of the 2-meter band, and you'll notice that the R value is 52.7 ohms. It's very close to a 50 ohm match. And 22 dB is the return loss, and 22 dB actually matches 1.17 SWR if you look on the charts that are available on the internet about return loss. This was the Rig Expert reading on the second antenna. As you can see, the SWR is lower, 1.10, 27 dB return loss, and 27 dB relates on the charts to 1.09 SWR, and the R value 48.8. I was very happy with this antenna, and it worked extremely well. Really nice gain. Everybody heard me very plainly, and I was about 10 over in communicating with other people with handheld. Here's the 3/8 inch copper that I wanted to put the rivet nuts on the end of. So what I did was, and there's a picture with the rivet nut already in it, the way I centered the hole to drill in that small 3/8 inch end cap, I took a 3/8 inch drill bit. I used the wood type drill bit that has a little bump out in the center of it. I stuck it in there and barely scored the inside of that cover, the end cap, and that gave me a starting point to drill. Then as you can see with the shot looking down the end cap, you can see the little mark that the drill bit put in there. So when I drilled it, it was pretty well centered. If it was off, it was off a millimeter, maybe not even. It worked out very well. Put the nutserts in, soldered the cap in, and everything looked pretty good. And here is a close-up of the nutserts inserted into the end cap. When I got ready to solder the end caps on so I had a good connection, you do have to take the copper and shine it up a little bit before you solder, apply paste, flux paste, and it worked out very well. Didn't interfere with the nutsert whatsoever. Here's a picture of the end cap soldered on with the nutserts, and then I inserted the bolts, which are adjustable, and on the second antenna I didn't need the bolts, worked out perfect, but the first one I did. This is just the short picture of the PVC as I put it together. I'm not going to give you a lesson on PVC. I'm sure you guys know how to do it. I'm always keeping my eye out for something I can use for testing. And that vertical stand is actually a volleyball net holder. There were 2 of them. They were brand new on wheels with counterweights. And the guy had them ready to throw out. And I said, "Can I have them?" He gave them to me. It's excellent for testing dipoles and for my 2-meter dipole test. And that's how I mounted it. And that's why I used the PVC with the bolt hole in it, because now I can just keep it vertical, the pole, the actual PVC vertical, when I put the antenna in it for testing. The one thing I want to mention is, I'll show you some readings that change in a minute. You must have the coax come down vertically. If you move the coax off to the side or move it horizontally, you get different readings on the antenna. But this antenna, as you were about to see, worked out very well. This was the average reading on this antenna, 1.01. It pretty much stayed there, so I started moving around the coax a little bit. You can see in this video that the readings were flat across the band. I couldn't have been happier. It really barely changed. You can see at the bottom there where it says minimum 1 to 1. That's at 146, 435. That's the exact resonance point of that antenna. But it was so close for the rest of the antenna that I couldn't be happier with it. There's another reading, but I was moving around the coax a little bit. And as you can see, the readings change a hair. But I'm going to strap that coax vertical so when I walk around with the meter or the handheld, it doesn't move. And that's the final reading. I got a 1.09, 27 dB return loss. Just excellent, excellent gain on this antenna. So in closing, I want to say I had a lot of fun building these. Each antenna took me hour and a half, 2 hours to put together. I did them after work one day, last 2 weeks ago, I guess it was. And, they worked out really well. So I hope you see what I've done. I hope I've explained it correctly. If you got stuff laying around the house, give it a shot. You never know what you're going to come up with. The real test will be when we actually go out into the marathon we're about to do and back in the woods and see if these things work out. I think we're going to test them before we go out there, but yeah, it worked out really well. Anyway, I really appreciate the viewers and the people that are watching these videos and the comments that I get. And I will see you next time for the next ham radio adventures. Again, this is K3MHW. I'm Mark, 73s, and God bless everybody.